actually. So please do remember from where we are starting this course. You can see that we are starting this course from the place of SDLC or the DevOps. What is DevOps? Okay, it's very, very basic level. We are going to start the course and we are going to end the course at very advanced level. Please do remember that. Okay. So our agenda for the today's class is going to be what is DevOps, what is an application, what is SDLC, what is server, okay, what are the types of servers that we have, or what is a physical server in those types of servers, what is Docker and Kubernetes, where does Docker and Kubernetes fits in a software release lifecycle process, SDLC process actually. Okay, what is DevOps actually? If you go, what is DevOps? DevOps is a combination of development as well as the operations, actually. Okay. What is a development in DevOps? Development in DevOps really does not mean the application development. Okay. It means that developing the scripts in a simple words, developing the scripts in order to automate the regular task which you are going to do, actually. Okay. So it might be the Python scripts, it might be the shell scripts, it might be the uh, Golang scripts or whatever, Golang programming, or it might be the this one, shell scripts and whatever you do. Whatever the manual activity you do, that should be automated by writing some scripts that comes under development in DevOps, actually. Okay. And the operations really means the maintenance. Okay. You have created some servers in the AWS cloud or whatever the cloud you take, and you have deployed your applications. Okay. You need to maintain that. Okay. You need to regularly maintain that. If any new version of your application is released, which is running on that server, you need to update the application version on that particular server. You need to provide the security patches. Okay. If any issues are occurring, you should be there to solve those issues, actually. So operations in DevOps really means the maintenance of your infrastructure and the applications that are deployed on the servers, actually. Okay. So that is DevOps, and DevOps people play a major role in bridge between the developers as well as the deployment, actually. So DevOps plays DevOps uh, will satisfy 100% reliability of the system in the production, actually. So DevOps is a major role in IT. So please do remember that. And uh, it's very important for the IT companies to follow the DevOps principles, actually. Okay. That is DevOps. And what is an application? In the next point is what is an application? Application is nothing but a website. Okay. You might be regularly using many applications in your day-to-day life, right? So we might be using Amazon.in, okay, Redbus.in, or whatever the Flipkart, or okay, these are all the applications that you regularly use. Okay. What is production and why it's needed, actually? So production means, production system means where our actual requests are going. Okay. So, suppose you have Amazon.in application. This is a question asked by one of the people in the chat. Okay. What is production and why it's needed? Suppose, let's deal with that question, actually. So, suppose what you mean is, suppose there is an Amazon.in application that you regularly use. Okay. Amazon people maintains three types of, like, for example, let's take Amazon people are maintaining three types of environments. Same Amazon.in application will be running in CI, continuous integration environment, CD, continuous deployment environment, and the production environment. These are the three environments Amazon people are maintaining in order to deploy their application: CI, CD, production. Okay. So these are the three environments. Okay. Same application is running. CI in the CI Amazon.in is running. In the CD Amazon.in is running. And in the production Amazon.in is running. Well, what is the difference? What is the difference? Difference is you are accessing the Amazon.in application and I am accessing the Amazon.in application. We are the real users of our Amazon.in application. So our traffic, okay, if we search for Amazon.in application in our browser, right? Actually, the traffic goes to production environment application, actually, but not in the CA environment application, CD environment application. Because they have deployed the same Amazon.in application in CI, CD for their testing purposes. But in the production, our actual traffic of the users will be going to the production environment, Amazon.in application. Okay, so this is an example actually. So did you get that point? That's a production where our actual user traffic will be going to actually. So did you get that? What do you mean by production? Yes, no, yes, yes. What's customer do with this? Oh, what you'll be doing with the Amazon.in application? That the customer do with that actually. Okay. Uh, uh, you know, you can purchase the products in Amazon.in application. You are a customer and you can purchase the products and you can pay your bills. Whatever the Amazon.in application functionalities provides to you, you can recharge your mobile. Okay, whatever. All these things customers can do with the Amazon.in application, right? So that's what the uh, customers do with it. Okay, so that's it. Okay. Now let's go with our agenda today. What is an application? Application is nothing but a website. It's simply a website, right? So where you regularly use, let's example of Amazon.in application and the Redbus.in application. Okay, these are all the applications actually. So now that's an application. It's simply a website, okay, which you regularly use. That's it. Okay. The next part is the SDLC process, how this application is developed. Okay. This application, see, for example, we are taking the old way, SDLC. People uses very modern ways actually. That's no problem. Just for your introduction parts, I'm taking this. Okay. So how the applications are developed? Okay, in the in the companies, people follows some methodology. Okay, they are going to take some method, whether it is a agile method or whether it's a STLC method. Okay, these are they are going to take some methodology and and they are going to follow that methodology in order to develop the applications. Okay, so let's take an example of SDLC process. In the case of SDLC methodology, how the applications are developed. Let's see that. Okay, so there are 6 phases in the SDLC process in order to develop an application. So the first phase in the SDLC process is analysis or the requirements phase that we call it as. Okay, in the requirement phase, what the people does? Okay, in the requirement phase, okay, so people collects the requirements. What are the functionalities needed in this application? How many people needed in order to develop this application? All the requirements in order to develop an application will be collected in the requirements phase of the SDLC process. Okay, that's a requirements phase or the analysis phase, whatever. Okay, the next phase, once the requirements are collected, the application goes to the design phase. What is this design phase? So design phase, people, UI, UX designers will be there, okay, or the system architects will be there, okay, in the design phase. So people are going to design the application. Designing means, suppose let's take an example, okay. So we have Amazon.in application again, same example, okay. So when you are going to log into Amazon.in application, it is going to ask you the username and the password, right? So that username and the password, where it should be placed on the screen, on the page, UI page. It should be on the top of the UI, or it should be on the top of the screen, or the bottom of the screen, left or right, or the middle. Okay. So in such kind of design will be performed in the design phase. The designing of the application will be performed in the design phase. Okay. So that's a design phase in the SDLC process. Once the application went through the design phase, next phase of the in the SDLC process, the development phase. Here is where our front-end developers and the back-end developers will take the design from the design phase and develop the application based on the design that is provided by the design phase. Okay, so that's a development. People chooses one programming language which is required in the like which is collected. Okay, it might be the .NET, it might be the Java or Spring Boot or whatever. They are going to take one programming language in the development phase, and they are going to develop the application in the development phase. And please do remember, in the development phase, people also write some kind of testing. Unit test cases, we are going to call it as. Okay, unit test cases. Initial testing is also done by developers. That is called unit test cases. We are going to write actually. So, uh, see, what is the testing means for the for this input. Suppose I have written some code. I am passing one number to this code. I am passing 10. The expected output from that particular code should be 20. Okay, is that output 20 is coming or not? But if we pass 10 to this particular code, okay, such kind of unit testing is going to be done in the development phase. Okay, so if you take Java in the development programming as a development programming, so they are going to use JUnit, Mockito, and the PowerMock tools in order to create unit test cases. These unit test cases also developed by the developers only. Okay, so that's the thing. Once the application code is being developed and the unit testing is done in the development phase, then the application goes to the developed application. The development phase goes to a testing phase. Here, the testers will be there. The application on the application, this testing people will be performing many types of testings: regression testing, performance testing, stress testing, or they are going to use many tools like Selenium in order to perform the testing on the application. So in the testing phase, actually, as an overall, our application is properly tested. Okay, our application is properly tested, whether it is working properly or not. Okay, so that's a testing phase. Once the testing phase is completed, here is where the deployment phase comes into picture. Because so that application need to be that application which is tested properly has to be deployed. Deployed means placed on a server so that the application can be able to uh, used by all the users actually. So the deployment phase actually. In the deployment phase, people deploys the application, and the application can be used by all the users actually. So in the deployment phase, okay. And the maintenance phase, once the deployment has been completed, the application should be maintained. There should be some users who need to regularly monitor the application with whether that application is properly working or not. Okay, if any new version of the application is released, they should be releasing that new version of the application. So all this will be done by the maintainers. Okay, who is maintaining the applications actually uh, in the maintenance phase. So this is the SDLC process that we follow in the industry. Okay, in order to develop an application. Okay, that's a 6 phases of SDLC that we need to go through. Okay, the thing, the next part of our agenda is going to be what is a server. Suppose you have developed an application. Suppose you have developed an Amazon.in application. Okay, the application is there in your local machine, right? The application is there in your local machine because you have developed in your local machine, right? So the application should be used by all the users across the world, right? So that is why you have developed your application, right? So how you should how you can make the application available to everyone in the world. Okay, you are going to deploy your application on a server. Server is a physical entity where you are going to deploy your application, and the application which you have deployed will be available to everyone in the world. Actually, that's a server actually. Okay, server is a place where you are going to put your application so that your application will be visible to everyone in the world actually. Okay, so that's an application. Okay, so now that's a server actually. Okay, the next part is where does Docker and Kubernetes fits in the SDLC process. Docker and Kubernetes fits as part of the deployment phase in the SDLC process because we are going to use a methodology of Docker and Kubernetes. The of Docker actually, and we are going to deploy that application in the deployment phase. Okay, Docker, please do remember, Docker and Kubernetes fits as part of the deployment phase. How it fits as part of the deployment phase, we are going to see in our course actually. Okay, please do remember that. Okay, the next part is, see, previously when the Docker and Kubernetes are not there, and one second, one second, please. Oh, sorry for the disturbance. Actually, someone called me and okay. Yeah, I'm mute actually. So, see, suppose before Docker and Kubernetes are not there, okay. So we are discussing deploying applications on the physical server, right? So when Docker and Kubernetes are not there, or the virtualization is not there, how people use to deploy their application on the servers actually, deploying applications on the physical servers. Okay, okay. There are types of servers actually. Before this slide, there are types of servers. Okay, physical server and the virtual server. Okay, so people initially used to deploy their applications on the physical server. Okay, what is physical server first? Your laptop is a physical server. Okay, so the server which you can touch, in a simple word, the server which you can touch, okay, uh and on which you can deploy your application is a physical server. Okay, so that's a physical server. Physical server is a physical entity on which you can deploy your application directly. Okay, that's a physical server actually. So here, the physical server looks something like this, okay, which I'm sure which is there in the diagram, and the people use it to deploy their applications directly on this physical server, okay, in order to be accessible to everyone in the world actually. So that's a physical server. Now, people initially, when the Docker and Kubernetes and the virtualization is not there, people use it to deploy their applications directly on the physical servers. Okay, people directly use it to deploy their applications on the physical servers. Okay, what happens? What happens if you deploy applications on the physical server? Let's see. Okay, let's see the disadvantage of deploying applications on the physical server and how people use it to deploy their applications on the physical servers. Let's see that. Okay, let me share this screen actually. One second. Okay, so I hope my screen is visible, right? So it's properly visible, right? Okay, so let me remove this. Okay, so let me put people deploying applications on the physical server, something like that. Okay. Please do tell me if you are if the screen size is very low. Okay. Uh, okay. Okay. Thanks for that. Okay. Please do tell me that, please, so that I can correct myself. Right. So if the screen size is very low, please tell me. I can increase the font. Okay. I think it's fine, right? So deploying applications on the physical server. Okay. So physical server example is your laptop is a physical server on which you can install your applications. You can deploy your application, something like that. Okay. Okay. Let's take. Okay. So people like this. Okay. Let me take the physical server. Something like this is a physical server which we are going to have. Okay. Okay. So this is a physical server. Okay. So let me take this is the let me label it something like this physical server. Sorry, this physical server has some amount of CPU and some amount of memory. Let's take this physical server has 10 CPUs, 10 CPUs, and 10 GB, 10 GB, 10 GB memory. Okay, let's take something like this. This physical server has 10 CPUs and 10 GB memory. Okay, please do remember that. This is an example. Okay, the physical server has 10 CPUs and 10 GB memory. Let's think that. Okay, so I have developed an application. Okay, suppose let's think I have developed this application. This application name is going to be app one. Okay, something like this. Suppose let me take real examples. Okay, Amazon.in. I have developed an application of Amazon.in, something like this. Okay, Let me select this. Okay, I have developed this one. I need to deploy this one onto the physical machine, physical server, so that it can be accessible by everyone in the world. Suppose I have deployed this Amazon.in application uh, on this physical server. Okay, so this Amazon.in application, initially, I don't have any business. Okay, when I started this Amazon.in business, application business, I don't have any users which are purchasing the products on my Amazon.in website initially. Okay, that is the reason. Initially, my Amazon.in application, which is running in this particular physical server, only required only required one one CPU, suppose one CPU, okay, and 1 GB memory, 1 GB memory. Okay, my Amazon.in application, which is running on this physical server initially, okay, where when I don't have any business, okay, when the no users are coming to my Amazon.in application, I only require one CPU and 1 GB memory. But this physical server is having 10 CPUs and 10 GB memory. Okay, what about remaining 9 CPUs and 9 GB memory left out here? One CPU and 1 GB memory is allocated to my Amazon.in application. And the physical server is having 10 CPUs and 10 GB memory. But what about the remaining? Okay, how many remaining? 9 CPUs, 9 CPUs, and 9 GB memory. Okay, right? So, memory. Okay, we have 9 CPUs and 9 GB memory that we have. Okay, remaining. Okay, this is if you deploy, this is one of the disadvantage. Okay, if you deploy your applications on the physical server, something like this, okay, there will be something called resource wastage. What is resources here? CPU and memory are the resources. Okay, we have deployed the Amazon.in application, and my Amazon.in application is using one CPU and 1 GB memory. Okay, but my physical server is having 10 CPUs and 10 GB memory. And out of 10 CPUs and 10 GB memory, one CPU and 1 GB memory is used by my Amazon.in application. And I left out with 9 CPUs and 9 GB memory. You can see that very clearly here, right? So first disadvantage that we need to discuss about if you deploy your applications on the physical server is the resource wastage. Resources means CPU and memory. They are wastage actually. These are wastage. Okay, 9 CPUs and 9 GB memory is a wastage. That is left idle. That is not used by any other things actually. Okay. So disadvantages of deploying applications on physical server. Subdomains. Okay, disadvantage of deploying application on the physical server. So the first disadvantage, what is that? Resource wastage. Okay, resource wastage. This is the first disadvantage that we have in case of deploying applications on the physical server. Okay, that's the first disadvantage. Next disadvantage. Okay, suppose I've started another business. Okay, suppose I have started another business, a insurance business. Still increase text is too small. Okay, is that fine? So is that fine? Do you want me to increase it? Increase or fine? Increase. Okay. Okay, I think it's fine, right? Okay, thanks for that. So the next part is I have started another business, that is insurance business. Okay, so for that insurance business, I have developed another application. Okay, that takes with life in like one second, what is that? Let me take this one. This is another application I have developed, and this is a insurance application. Let me take insurance.com. Insurance.com, something like this. I have developed another application, insurance.com. Okay, this is another application that I have started. I've started another business, and for that I needed another application, that is insurance.com. Okay. And this insurance.com need to be deployed, right? In order to get the traffic, and in order to serve the traffic, in order to send the real traffic actually. So in order to deploy this insurance.com, you cannot deploy on the same physical server. Okay. You need to purchase another physical server in order to deploy this insurance.com website. Okay. Even though we have 9 CPUs and 9 GB memory, you should not deploy this insurance.com in the same physical server. You need to purchase another physical server in order to deploy this insurance.com application. Okay. So if you this is the second disadvantage that we have. Okay. If you want multiple applications to be deployed on the physical server, even though the resources are there on the existing physical servers, you need to purchase new physical servers actually. So if you want to purchase new physical servers, you need to spend a lot of amount of money. That's the second disadvantage. If you deploy your applications on the directly on the physical server, the cost usage is very high. Okay, the usage, the cost is very high. That's the second disadvantage that we have. Okay, so the second disadvantage is high cost. Let me put it here. Second one is huge cost. Huge cost. Okay, that's the second disadvantage. Okay, suppose we have money, the organizations had money, and they have purchased multiple physical servers in order to deploy multiple applications, right? So even after purchasing multiple physical servers in order to deploy multiple applications, you need to have one big space to install this physical server, to place these physical servers. You need to pass air conditioner. You need to have air conditioners. You need to have a separate team in order to maintain these physical servers. So there will be this maintenance team unit is to regularly ensure the security, and regularly ensure the disaster recovery, regularly maintain the physical servers. So all these things are there if you directly deploy your applications on the physical servers. Okay, so there is a high maintenance. If you deploy your applications on the physical server, they incur very high maintenance actually. So you need to maintain a separate team in your organization so that your physical servers are properly maintained. So there will be a high maintenance if you deploy your applications on the physical servers directly. Okay, let me take this one. The third disadvantage that we have is going to be high maintenance. High maintenance. Okay, that's it. Okay. The next disadvantage. Suppose uh let's remove this actually, insurance.com. We need to write one more point there. Okay. So yeah. Please suppose let's say something happened to the physical server, and this physical server got crashed. This physical server got crashed. Okay. This physical server got crashed. Okay. The Amazon.in application that is running on that physical server will also be crashed. And tomorrow there is a sale in my Amazon.in application. Now, what we can do now? Okay. Again, we need to spend lot of amount of time when the application when this server is crashed. I need to take this application, purchase a new physical server, and deploy this Amazon.in application on the new physical server manually. Okay. So there is no high availability if you deploy your applications. So high availability means in any case, whether the physical server is crashed or whatever it has been done, until and unless we don't have a issue with the application. At any case, our application should be in a running state, that is high availability. Okay. In case of physical server, there is no high availability. Uh, Actually, so control set. Okay, if the server is crashed, something like this, our application is also crashed. There is a lot of activities that need to do if Amazon.in application is crashed. Okay, so we don't have, in case of deploying applications on the physical servers, we don't have high availability. HIGH. Okay, let me take one more example of high availability. Suppose if you take Amazon Cloud. Amazon Cloud. What this Amazon Cloud people does in suppose if you take a Mumbai region where the Amazon.in, Amazon AWS Amazon Cloud data centers are there. They have data centers in the in the Mumbai region actually. Okay, for doing this high availability, for achieving this high availability, what this Amazon Cloud people did is they have not put all the data center at one place. They have put data center in three regions in the same Mumbai region, in the three places in the same Mumbai region. Okay, if the application is, suppose we have deployed application, same application across all the three places. If one place server is crashed, other two places are there in order to serve our traffic. Such kind of mechanism is not there in deploying our applications on the physical server. If the server is crashed, then that's it. Our application is crashed. Okay, that's how we have disadvantages if you deploy your applications on the physical servers. Okay, so these are like this. We have so many disadvantages if you deploy your applications on the physical servers directly. So first disadvantage that we have seen is the resource wastage and the huge cost. If you deploy multiple applications on multiple, if you want to deploy multiple applications, you need to have multiple physical servers. You need to purchase multiple physical servers. That will incur huge amount of cost for you. And even though if you purchase that physical servers, if you have money and purchase the physical server, you need to have big room, and you need to you need to have power supply, and you need to have the air conditioners, and you need to have separate team in order to maintain that. There will be high maintenance. Okay, so if you deploy your applications on the physical server, and the next disadvantage that we have seen is no high availability. The application is maintained is it only one place. If the server is crashed, if the physical server is crashed, our application is automatically crashed actually. Okay, so those are the disadvantages that we have faced. Okay, there are a lot of like this, but yeah, let's stick to this. If you keep on discussing, that will be keep on coming. Okay, so because of these disadvantages, in order if we deploy our applications directly on the physical server, we have virtualization. Virtualization is evolved actually. What is virtualization? Okay, what is virtualization? We are going to see. Okay, any questions until here, please? Anyone have any questions? Anyone, please? Anyone have any questions? You can put it in the chat. I can see that if you have put in the chat. Or all clear, just respond something so that I can understand that you are listening and it's all clear. No, no. If you deploy other applications on the same server, that will be security breach actually. Okay, hackers, if you enter into that one server, they can also access other application also. So people should not deploy two different applications on the same server, right? So I should not deploy that. Okay, suppose you have banking application as well as Amazon.in application on the same server. If something happened and the hackers has tried to enter to the Amazon.in application in that server, and on the same server we have banking application as well. So in that case, right? In that case, hackers, if we enter in this particular Amazon.in application, okay, they can easily enter to the banking application also because they are in the same server. Okay, so there are high chance of entering that one. Okay. So that's why you should not deploy the same applications, two different applications on the same server. Okay. Disadvantage is low availability, right? Yeah, it's also disadvantage, low availability, also a disadvantage that we have. Sorry, no, sorry, I think it should be something no high availability. That what I need to enter. No high availability. No high availability. Sorry. So sorry for that. Okay, it should be something like this. No high availability. Not present or something like this. Something like this. Not present. Okay, something like this. Ah. Thanks for that. Thanks, Anadi, for saying that. Okay, so that's the thing. So because of the disadvantages that we have in case of physical servers, we have virtualization and the virtual servers are involved. What is virtualization? How the virtualization looks actually. So let's deal with virtual concept. Suppose let's take this is going to be in the virtualization also we will be having our physical servers. Suppose this is going to be our physical server. This is our physical server we are going to have. Okay. So let me take this is a physical server. This physical server is having 10 CPUs and 10 GB memory. Again, same example I'm going to take 10 CPUs and 10 GB memory. Okay, something like this. Okay, this is a physical server. Okay, so this physical server is also having 10 CPUs and 10 GB memory. Please do remember that. Okay, now on this physical server, you will be having something called operating system. Okay, you'll be having something. So you'll be having something called operating system. Okay, so you'll be having something like this. Okay, so you'll be having something called operating system. Here is the operating system. On which what you are going to do, you are going to install virtualization software. Suppose you might have installed on your local machine, right? You might have installed Oracle VirtualBox on your local machine. You might have installed Hyper-V, hypervisor, whatever. Okay, on your on your local machine. So suppose the physical server, let's take is your laptop on which you will be having your operating system, okay, with Windows operating system, on which you will be installing Oracle VirtualBox. That's the virtualization software. What that virtualization software help us to do? That virtualization software will help us to create multiple servers on the same physical servers actually. Okay, so let me show you. Okay, let me have this one. Suppose this is going to be our virtualization software that we have deployed. Okay, we have installed. Okay, so this is virtualization software. It might be the hypervisor. There are multiple virtualization software that are available in the market. Okay, hypervisor, Oracle VirtualBox, Hyper-V, VMware. So all these things are virtualization softwares that are available in the market. You can use any of the virtualization software based on your requirements. And so let me take hypervisor. Hypervisor we have installed as a virtualization software as part of this physical server. Okay, that's the thing. Now, what this hypervisor virtualization software will help us to do? That's what the question, why we have installed that. This help us to create multiple servers in a same physical server. Suppose this is the one server that can, or this is a server that can be created. Okay, command C, command V. Okay, this is a second server that can be created, something like this. Okay, so something like this. Okay, command V, and the third server that can be created. What this virtualized software, the hypervisor will help us to do, this hypervisor, which we have installed on our physical server operating system, will help us to create multiple servers on top of this one physical server. Okay, this multiple servers are called virtual servers, okay, or the virtual machines. Okay, so we cannot touch those virtual servers because they are virtually located, and only we can interact with that servers actually So these are virtual servers. Okay, so hypervisor will help us to divide and our entire physical machine into multiple machines. Those are our virtual machines or the virtual servers. Okay, you can see that something like this here actually. So let me label that one here, virtual server. Okay, let me label that one, virtual server, something like this. Copy this one and let me put it here as well. And let me put it here as well. These are the three virtual servers or the virtual machine that we can create based on the availability of resources, availability of CPU and memory on the physical server. You can create multiple virtual servers on top of this physical server actually. Okay, so let's think this each virtual server. Sorry, let's think this each virtual server is allocated with uh, 3 CPUs and 3 GB memory. How much amount of CPU, how much amount of memory is there on the physical server? 10 CPUs and 10 GB memory is there. Out of those 10 CPUs and 10 GB memory, 3 CPUs and 3 GB memory is allocated to them. Something like this. Okay. Okay, something like this. This also it's allocated for this. Sorry. And here also it is allocated for this. Out of this 3 CPUs and 3 GB memory that are there, 10 CPUs and 10 GB memory that are there for this physical server, 3 CPUs and 3 GB memory allocated to the each virtual machine or the virtual server created on top of this physical server. Okay, that's what you need to remember. Okay, now same example, let's take, okay, Amazon.in application and the insurance.com. We have two different applications, that is Amazon.in application and the insurance.com. Okay, let me take this one. Okay, so AMA.in application. And we have, let's take insurance.in only. Okay, no problem. So let me take something like this. These are two applications that I have developed. I started business. Okay, so insurance.in. These are two different applications that we have. Something like this. So I need to deploy these applications now in case of virtualization and the virtual servers. Okay. So now what I can do, it's a beautiful concept. You can see that here we can deploy the first application in the Amazon.in application. This first the application Amazon.in in the first server, something like this, and insurance.in application on the second server. Something like this. Okay. I'm going to make this a little bit small. Okay, 1 second. Let me put this one. Insurance.com. Dot something like this. Okay. I can run Amazon.in application in one physical server, so one virtual server or the virtual machine, or the insurance.com in the another virtual machine. Here, in this case, you see that for deploying multiple applications in case of virtualization, if you see that, I'm deploying multiple applications in case of virtualization here, but I need only one physical server. But in case of deploying multiple applications, in case of directly deploying multiple applications on the physical server, you need to purchase multiple physical servers, right? You need to purchase multiple physical server and you will be costed, right? The disadvantage, huge cost is gone. The cost reduction will be greatly there in case of virtualization. In case of virtualization, you will be having very great cost reduction, because instead of maintaining multiple physical servers, you are going to maintain only one physical server, and you can deploy multiple applications on the same physical server using virtualization and the virtual server concept. Okay, so the disadvantage that we have in case of physical servers is gone. A huge cost is gone in case of virtualization and the virtual server, something like this. Okay, so that's the thing. Now, if I don't have multiple physical servers, right? I only have one physical server. I'm deploying multiple applications on that one physical server only. So if I have multiple physical servers, I have multiple applications. Okay, I have multiple applications, and I and I am deploying multiple applications from the same physical server only. I need to maintain only one physical server in order to deploy multiple applications. I know it of maintaining multiple physical servers. So the disadvantage of high maintenance is gone in case of virtualization on the virtual servers actually. Okay. And these virtual servers, please do remember, these virtual servers are maintained in the cloud. Let's deal with the cloud actually. These virtual servers are maintained in the cloud. Okay, because virtualization and the virtual server are greatly used by the cloud in the by the organizations actually in the cloud by the organizations. Okay, so these physical servers are previously used, and now the virtualization and the virtual servers are used by the organization with the help of the cloud actually. Okay, so now instead of maintaining multiple physical servers in order to deploy multiple applications, I am going to maintain only one physical server and deploy multiple applications on the one same physical server using virtualization and the virtual servers concept. And the high maintenance is gone in case of virtualization. Okay, so that's a high maintenance disadvantage is gone. Now, in case of high availability not present, in case of the disadvantage that we have seen, high availability not present as part of the physical server. In case of virtualization and the cloud, there will be high availability. Again, the same example. Let's take in the Mumbai region. They have their data centers in the Mumbai region. Not in only one place. They have three different places where they have hosted their data centers actually. So the application Amazon.in will be running in the multiple availability zones, we call it as in the Amazon terminology. Okay, so multiple data centers, so that even one data center is being crashed, other data centers are there in order to serve the traffic, in order to serve actual traffic, actual user traffic actually. So there is an high availability in case of virtualization on the cloud, but not in case of physical servers, because physical servers, if you are using, you need to maintain, your organization need to maintain, okay, those physical servers. But if you are using virtualization, you can use the cloud, Amazon, and the Azure, and the GCP, whatever the cloud you use. This disadvantage that we have, high availability, is gone in case of virtualization on the cloud actually in this particular place actually. Okay, so now the other disadvantage is resource wastage. You see that the left out disadvantage that we have is the resource wastage actually. Okay, so now resource wastage is still there in case of this physical server and the virtualization. Okay, suppose out of this 10 GB memory and 10 CPUs, I have said that 3 CPUs and 3 GB memory is allocated to each physical server or each virtual server. You see that 3 CPUs and 3 GB memory is allocated to each virtual server. I have put that points here, right? So let's think initially my Amazon.in application is only using 1 CPU and 1 GB memory. 1 CPU, 1 CPU, and 1 GB, 1 GB memory. Okay, so okay, we have 1 CPU and 1 GB memory used by my application, Amazon.in application, and the insurance.com application is also using 1 CPUs and 1 CPU and 1 GB memory. Right. Now, how much amount of CPUs and how much amount of memory is there with this? 3 CPUs and 3 GB memory is there with this virtual machine. But out of those, 1 CPU and 1 GB memory is used by my Amazon.in application. Sorry. What about remaining 2 CPUs and 2 GB memory is left out idle? Okay, remaining, we have two CPUs, two CPU, and 2 GB memory is left out. Okay, I will. Okay, they are resource wastage. Again, the resource wastage is there. Okay, in case of deploying applications on the virtual machines or the virtual servers. Okay, so here I hope you understood the point. All these disadvantages, huge cost, high maintenance, high availability not present. If you deploy your application of physical server, is gone in case of virtualization, but resource wastage is still there as part of your virtualization concept. Okay, as part of your virtualization concept. Okay, this I because of this reason, not only this reason, let's think this is the reason. Because of this reason, in order to use full amount of resources, a Docker has been evolved. And another reason why the Docker has been evolved because of the evolution of microservices. Okay, we are going to discuss those microservices evolution tomorrow and how the Docker will be installed on the virtual machines and the physical machine. We are going to discuss in the tomorrow's class. Actually, I think the time got completed. Okay. So that's how it is. Okay. If you have some time from your side, I can explain today also. Do you people have some time for me? Okay, someone, yes, sure. Okay, uh, someone asked, so those three virtual servers are not sharing any memory. Yeah. You see that they will be having individual memory actually. Okay, so something like this. They are taken from the 10 GB memory that is allocated to the physical server. Yeah. Okay, something like this. Okay, because of this, because of the disadvantage that we have with the physical server, like let's take an example of this one, the resource wastage, a Docker has been evolved. And other reason why the Docker has been evolved is the evolution of the microservices. What are microservices? That you need to understand first. Okay, microservice, let me take this here, let me draw it here under this actually. Suppose you have Amazon.in application. You have Amazon.in application. Okay, so this Amazon.in application before the evolution of microservices, okay, people used to develop all the functionalities in the Amazon.in application as a single entity, single application. Let's take Amazon.in application will be providing payment related functionality. Amazon.in application will be providing cart related functionality. Cart means you can add your items to the cart. Amazon.in application will be providing electronic goods functionality. Amazon.in application will be providing the clothing functionality. All these functionalities will be put together and developed as a single application previously, that is called monolithic application that we call it as. Okay, all the applications, all the functionalities that is provided to us by the Amazon.in application is developed as a single application. That is something called monolithic application. Okay, so previously, suppose let's think this is a monolithic application. Amazon.in. Okay, monolithic application. Okay, something like this. Something like this. Okay. Okay. So what are the disadvantages we have in if you develop this Amazon.in application as a monolithic application actually? Okay, disadvantages are something like this. A small change in small functional. Suppose a new bank has been come into the market, XYZ bank, and I want to allow the payments from that particular XYZ bank actually. Okay, so if I want to allow the payments from Amazon.in application from the XYZ bank, I need to change the payment functionality code. If a small change in the payment functionality code in case of monolithic application, you also need to change all the other functionalities code. Actually, you need to change the card functionality, you need to change the electronic goods functionality, you need to change the clothing functionality, because in the Amazon.in application, as it's a monolithic application, uh, the functionalities will be dependent on each other. The functionalities will be dependent on each other. A small change in the payments related functionality that also affects that affects card related functionality, that affects electronic goods functionality, that affects the clothing functionality. So a small change in the payments, you need to change all these functionalities application code in case of monolithic, because they are dependent on each other. Amazon, clothing is dependent on payment. cart is depends on payment, and this one, what is that? Electronics is dependent on payment. Okay, so all these functionalities need to be changed. Okay, so there will be a huge high amount of work in this place actually. Okay, this is the first disadvantage if you develop your applications as monolith. Okay, the second disadvantage is if you choose one programming language, suppose let's take Java, entire application for payments, card, clothing, electronics, all these functionalities should be developed in that programming language only. You cannot use multiple programming languages based on your requirement for each functionality. You need to use a single programming language in order to develop this monolithic application. Like this, if you keep on talking, we have multiple disadvantages. Suppose we have changed the functionalities. Okay, suppose we have changed the code. Okay, suppose XYZ, same example, let's take XYZ bank has been come into the market. We need to allow the payments from that XYZ bank, right? So we have made the required changes in all the functionalities. Let's think, right? So let's take Amazon.in. These changes has to be released into the production. Okay, because where our this production is the place where our actual traffic comes into picture, right? So if you want to release this updated changes to the production application for small change in the payments functionality, all the application code is changed. Amazon.in application, let's take in order to release in the production environment, all the functionalities in the production environments need to be restarted. Okay, so because all the functionalities are being changed because of the one small change in the payments, right? All the functionalities need to be restarted in the production environment. If you restart all the functionalities in the production environments, let's take Amazon.in, as it's a huge application. Let's take an example. It takes 20 minutes of time to restart all the applications. We don't know after 20 minutes the applications comes properly or not, but yeah, it takes 20 minutes to restart the applications. Now, think about if the Amazon.in application is down for 20 minutes, how much business impact the people will be having. Okay, how much business impact the Amazon.in application will be having. So these are such kind of disadvantages are there if you develop your applications as monolithic application. Because of these disadvantages, we have microservices concept is evolved. So each functionality is in Amazon.in application is developed as a separate application. Okay, so this is the payment. First, this is a cart, and this is a clothing, and these are electronics. Okay, these are electronics. Let me label that. Okay, these are individual applications. They are being developed as a separate applications. Why? EMT, yes, payments. This is going to be the cart, and this is going to be the clothing, and this is going to be the electronics. Electronics. So each functionality in the Amazon.in application is developed as a single separate application, and there will be a communication between these applications. Actually, clothing can be talked to payments in order to pay money for the cloth selected, and clothing can talk to cart because once the cloth is selected, you can add the clothing to the cart, and this electronics can also be talking to cart, right? And this electronics can also talk to the payments, right? Something like this. You cannot directly do the payments, and the cart can also talk to payments, something like this, in order to pay the uh, pay money for the items added to the cart. So something like this. So there will be a communication between the microservices. These are something called individual applications. These are individual applications. Instead of developing in the same application, multiple functionalities are developed as a single separate application. These applications are from nothing but microservices. Microservices. Okay. So these are applications are nothing but microservices. Suppose let's take a same example again. A new bank has been coming to the market, XYZ Bank, and this microservices related like architecture, the applications are not dependent on each other. Okay, so here, if I add that payments related functionality, update the code of payments functionality, payments application, you no need of changing the clothing application, electronics application, cart application. So in case of monolithic application, if you change the 20 minutes of time it takes to come up in the production, but in case of this microservices world, you only need to restart payments related application, but not cart, electronics, and clothing. The payments only need to be restarted, but not cart, electronics, and clothing. So it from the 20 minutes of restart time in the case of monolithic to 5 seconds of restart time, how much greatly reduce the restart times actually. So that's how the power of microservices. In case of Docker, what you are going to do, each application here, you are going to convert into a Docker image and the Docker container. What is Docker image and what is Docker container? We will be discussing, but each application here, we are going to convert each application here into separate Docker images and Docker containers, and you are going to deploy these applications on the Docker host actually. What is this terminology? What is Docker host? What is Docker container? And what is Docker image? We are going to see previously in the next future classes, but do remember. So each application is created as a Docker container. Okay. So because of this evolution of microservices, also Docker is being famous nowadays actually. So Docker and Kubernetes is very important nowadays for the IT people because for the developers and the DevOps engineers to work with those actually. So that's the evolution of Docker. That's how the Docker is being evolved. And we are going to uh, see the Docker related concepts from the tomorrow. So I've laid a proper step like from where the Docker is evolved, for how people need to deploy, uh, how the people used to deploy previously, right? Applications previously, and now how people are deploying, and in the middle, like how the virtualization concept, how the people use to deploy, and after that, using Docker, how the people are deploying. We are going to see. So I have laid some path, so you will be understanding very clearly in that manner actually. So if you have any questions, you can ask any questions, please. You can unmute. Yes.
Yeah, hi sir. This is Raviraj.
Yeah.
So
Tell me.
you have explained regarding virtual machine, right? So this one VMware.
Yeah. Yeah.
Virtualization. Sorry. So here
Yeah.
we haven't come to Docker yet, right, sir?
Yes. Yes. We have not come to Docker yet. We are going to see tomorrow.
Okay. So this virtualization here it is providing us different servers within this
Yeah.
one physical server. So
Yeah.
just it might be a bit early to ask. Just had one query. So what is the difference between this virtualization and EC2 instance which AWS provides?
Same thing. Okay. Here, virtual server which you are calling here, the EC2 instance are same. Okay. In the AWS terminology, it's a EC2 machine or the EC2 server, or EC2 instance, whatever. Here, as an example, it's a virtual server. It's a EC2 machine also is a virtual server. It is actually running on the physical server only in the AWS data centers. Same thing actually, no difference.
Okay, it will not be visible as we will create our own instance.
Yes.
Same
Yes.
way as we are creating in virtualization.
Yes. Yes.
Okay, sir. Okay, got it. But nowadays, virtualization, this one, like a lot of people are not using VMware and right.
Yeah, yeah. See, people won't use this hypervisor software actually. AWS people itself installs that. Whatever the virtualized software feasible for them, they will be installing this hypervisor. Previously used to install directly. If you are, see, suppose if you purchase your physical servers, you should install. But as nowadays people are using cloud, people are not installing this virtualized software. AWS people by themselves installs that virtualized software, and they will give us a platform, and we can create the virtual servers on top of that virtualization software actually. So that is why we are able to create EC2 machines, because there is a virtualization software on the physical server they have in their data centers actually. So
Understood, sir. Clear. Now doubt
yeah,
is clear.
yeah.
Yeah, so from tomorrow we are starting with Docker, right?
Yes, yes. From tomorrow, we are going to start with Docker, and we are going to install Docker, and we are going to see some terminologies of Docker. So because yeah, that's it.
Yes. Thank you.
Yeah, thank you. Yes, yes, I'm going to create the account creation and all the steps that are involved in the account creation. No problem with that. I can show you the account creation steps. No problem. But it's very easy. I cannot go further. You should have email account, or what we can do if you want an account creation. I can if you are facing any issues, I can join a call with you in the because you cannot share your screen as part of the sessions actually. So we can join a call using Google Meet or whatever. I can help you there with the account creation and all the steps that are involved. No problem with that for me. Okay. Is that fine? Or
Yes, sir. Is that fine? And you told in DevOps everything is automated, means using scripts we will automate all the things which are deployment and everything, no?
yeah,
Hello.
yes, we are going to. Yeah.
For that we need some language, means shell scripting or Linux we need
No,
to
no,
know.
no, no, no,
Have
no, 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 no. It's a YAML. It's a YAML
okay,
actually. So
everything is going to happen in YAML file. We need to
YAML format.
configure.
Yes. And
Okay.
in Jenkins, when we are using Jenkins, right? So you are going to write some declarative pipeline syntax. That's not a YAML. Uh, uh, that one is something different. Actually, it's very easy. Do not. It's not a programming language. You're not applying any logic there. It's very easy. It's a declarative again, but it's different syntax. It's a syntax. That's it. You can easily practice and you can easily get that. It's not a logic or programming itself.
Okay. Without knowing shell script also, we can go with learning the Jenkins and Kubernetes.
Yes.
Okay. Nice. Thank you.
Okay. If you are liking the course and yeah, Bhavani Gaur, can you ask me a question? What is your question now?
My question, particularly on Kubernetes, are we going to install Kubernetes on a virtual machine and then creating cluster, or we just using EKS?
No. Yeah, we are going to use EKS because as nowadays, no one are using the physical server Kubernetes clusters actually. People are using cloud provider Kubernetes clusters, EKS, AKS, or GKE. You're going to use the EKS cluster as part of our course. But yeah, but installation part I'm going to show, but we are not going to deal with the physical like KubeADN cluster or the COPS cluster or K3S cluster. We're not going to deal with that. We are going to deal with EKS.
Why I'm asking this, because I just want to understand how actually it is work on-premise Kubernetes. We have on-premise Kubernetes, OpenShift, etc. So
okay.
You're absolutely correct.
I can show how it will work, but not entire course will not deal with that. Actually, we are not going to deploy that on the physical service.
Okay.
Yeah.
Sir, are we having classes on Sunday also, or only?
No. There are no classes. No class on Sundays and Saturdays. We will be having class on weekdays only, Monday to Friday. And please do remember your session timings will be changed to 8 a.m. morning, but not 9 a.m. every time. After few days, 3 to 4 sessions, your sessions are going to be shifted to 8 a.m.
Morning 8 o'clock.
Yeah.
For tomorrow, at least
IST.
9, right, sir?
Yeah, tomorrow is 9 a.m. only.
Okay.
Until I say it's 9 a.m. only. If the if the classes are shifted to 8 a.m., you can I'll be telling you.
Shiva, I just have to be enrolled for Docker and Kubernetes class. Then that is starting immediately after the payment link is start, or as you said that the class will be shipped to 8 a.m. So what?
Yeah.
And when you are going to start Docker Kubernetes in 8 a.m. class?
No. I'm starting the Docker tomorrow only. We cannot start Kubernetes directly without Docker. Okay. We are going to start Docker tomorrow only, actually. So yeah, that's how. It's in demo class also we are going to discuss Docker, and tomorrow I think the last demo class. Let me discuss that with the like Durgasoft people so that I can understand what is the last demo class. I think mostly tomorrow, and a day after tomorrow the continuous sessions will be there, but the link is going to be changed actually. So that's what I need to explain on it.
Sir, once after the payment, like what we need to do?
How you are joining with the demo link? Same way you need to join.
No, like do we need to share the screenshot to anyone or like?
This one, yeah, you are going to get. I have pasted some details in the chat, right? So you can follow those.
Okay. Sir.
Yeah.
And sir, like
Okay.
for tomorrow, sorry to ask the last doubt.
No problem.
So tomorrow, like the Dockers and everything will be installed in the AWS itself, right, sir? Like.
Yeah. First, we are going to see some diagram, and then we are going to see Docker installation and creation of EC2 machines and all, because you need to create an EC2 machines. Everyone might have not known. Like some people might have not known. So I'll be going with that some of the cloud concepts, and we are going to install Docker on the virtual machines or EC2 machines.
Okay, so we are not installing it in local machine, right?
No.
Okay.
No. Because you can also install, no problem. But if your local machine, see, Docker is going to take high amount of resources in your local machine. It might, if you have very low CPUs and very low memory of your local machine, right? So it might slow down all other applications in your local machine. So I don't want you people to face any problems with your local machine actually by installing Docker. That is why I suggest to install Docker on your virtual machine actually. So I have installed Docker in my local machine also, no problem for me, because yeah, that's fine for me. And if you have very less amount of resources with your local machine, you should install Docker on the virtual machines in AWS cloud, not on your local machine.
Okay, sure. Thank you, sir.
Yeah, thank you.
Sir, is there any prerequisite that we should have Windows operating system 10, 11 like that, or?
No, you can use whatever the operating system that you have, you can join actually, no problem. No prerequisite with respect to operating system actually. Sorry for that. Yeah, no prerequisite actually. If you have Windows, a small software that need to be installed on your local machine, that is nothing but WSL, Windows Subsystem for Linux. Okay, so that need to be installed. That's it. Other than that, there is no. Without installing, also you can manage from the AWS cloud servers actually. You no need of having any prerequisites. Okay, so that is session for today. Thanks for joining. If you are liking the course, I have pasted the details in the chat. Please go ahead and register for the course. The link is going to be changed soon. And thanks for joining. And we'll meet in the next class at the same time, 9 a.m. Thank you. Thanks, everyone. Bye.